In this video, we are working on our first memory piece or graphic organizer. So I'm going to turn to that section in my notebook. Well, I said I was. There we go. And you should have these pieces for the scientific method. There are 8 of them, and you should have cut those out. If you haven't already, it's fine. Just stop this video, cut them out, and you should have 8 different pieces once you get that done. And we'll fill these in, and then we will talk about what to do with them after that. So the first one is the one that says question. This particular picture is called a Frayer model. It's a model that's used in all levels of education. I've used them in college a lot to help you learn new concepts and really help you remember them. And the purpose of these graphic organizers is to put this information into your memory. That's why the pieces are hands-on. It's important that we're not just copying things out of a book. Your brain needs lots of different ways of putting information in order to process it the best. So this is a hands-on activity. There's a purpose for that. It's not just to have something to do. It will help you learn these steps and remember them. So with this first step, we have the question process. And in this first box up here, it's asking me what it means to question with respect to the scientific method. So here's what we want to add in the question, what it means. When you are a scientist and you question something, you write that up as a research question. So it means to write a research question that you want to answer. And how to do it. You start this process with observation. You observe something, and remember that can be see, smell, taste, touch, or feel around you. That leads you to a question. That's literally how every scientific discovery has been made. Someone is looking at the world around and asking questions about it. That's how Newton discovered gravity. The apple fell on his head. He said, why does the apple fall down? Why doesn't it fall in different directions? So you observe something around you that leads you to a question. And here is our example. I'm going to walk us through an example of practical implication that will help you understand each of these steps. So I'm going to just make up a name. I'm going to use a man named Sam. Sam feels, so that's an observation, very tired. Sam looks very pale. His face is very white. He's not looking healthy. Okay. Sam, here's the research question. Sam asks himself, why? So there's the research question. Why do I feel tired and why do I look pale? Okay, so let's just think about that in the course of everyday life. Do you ever feel tired? Do you ever look pale? Sure, we all do. In fact, that's a weekly occurrence for me. It's not at all unusual. But that's the beginning of an unusual situation for Sam. Okay, so Sam decides to go to the doctor. He decides to go to his physician to find out about this situation. Okay, this piece is done. The next one you want is the research piece. So what it means. What does it mean to research something? You must collect data. To answer your research question. And I'm going to abbreviate research question as RQ. So let's go back to the other one. And where it says research question, I'm going to put RQ. So we remember what that RQ stands for. RQ, research question. So you collect data to answer your research question. If you are in the situation where Newton was looking at gravity, he collected data about how things fall. When Copernicus was looking at whether or not the Earth was flat or round, he looked at data about how the sun moved in the sky. So every scientist has to collect data. How to do it, and this is important. You can't just go out there and randomly start collecting data. You must follow a specific plan that can be reproduced. So to collect scientific data, you want to do it in a way so that another researcher can reproduce your experiment exactly the way you did it. And research does not necessarily mean experiments, okay? Research is data collection. It's observing more. We could even say that. Observe more. You might look at what other people have done. All of this is part of the research phase of the scientific method. Okay. So back to our example of Sam. How could Sam research his situation? Well, one thing he can do is go to the doctor. He might also talk to others about his condition and find out what they have, when they felt that way, what was the cause of that. He could also do some, like, check his blood pressure at home. That would be one of the things I would do if I started to feel very tired. I would look at my blood pressure. He might even track his sleep. Maybe it's because he's not sleeping enough. He could do that on an Apple Watch or a smartwatch, or he could just keep a log of how many hours he's sleeping every day. There are lots of things you can do to do research. But I'm going to go with this first one. Sam is going to go to the doctor. But first, well, let's say when he goes to the doctor. We're going to just go ahead and say Sam makes a doctor's appointment. Okay, so when you make a hypothesis, you are going to state in sentence form the educated guess to answer your research question. So in Sam's situation, he's going to go to the doctor, and he and the doctor are going to come up with a hypothesis. In the way you make a hypothesis, you consider all your research, and this is important that you consider all of it. You need to make sure that you consider all sides, not just the side that supports your hypothesis. You consider everything that you've learned. And then you write your statement. You literally make a sentence that says what you believe to be true. Okay. So in our example, Sam goes to the doctor. Let's add a little bit to the research. So I'm going to go back to this card just a minute. Doctor finds that Sam's blood pressure is very high. It's very high. It's higher than it should be. And he also finds that Sam's oxygen levels is low. His oxygen levels are low, or his oxygen is low. He's maybe in the lower 90%. Oxygen should be in the upper 90s. So maybe Sam's is around 92, somewhere in there. So here's the hypothesis. The doctor's going to consider his education, what he's learned in school. He's going to consider Sam's data, what he's seeing on the data. And here's his hypothesis. Let's not use the word I. Let's say that the patient has a heart problem. That's a hypothesis. That's an educated guess based on the research. Now, is this for certain the explanation? Are there other things that could cause Sam's symptoms? Sure there are. I just got through COVID and I had those same symptoms, and I don't have a heart problem. So the doctor's hypothesis is just an educated guess, but we don't know at this point if it's true or not. Okay, so how do we find out if it's true? What is the next step in our story? And that will go with the experiment step. Experiment means to develop a plan and then use the plan to test the hypothesis. Okay. This is not just a stab in the dark. You develop a plan. Doctors have a treatment protocol that they learn in school. That's the plan. And you use that plan to see if your hypothesis is correct or not. So, how to do it? You need to come up with a plan. And it's important that that plan is based on science. For example, in our story, my grandmother always said that you could tell if someone had a heart problem by looking at the size of their eyes. Okay, I don't know if that's true or not. I don't see a connection personally, but that wasn't based on science. That was just what my grandmother's grandmother told her. We need a plan that is based on science, and you have to follow that plan. This is so important because remember, we want it to be something that another person could do and see if their results match ours. So you have to follow the plan exactly. So in our story, what would the doctor's plan be if he suspects that Sam may have a heart problem? What would be some of the things that the doctor would do? Okay, step one would probably be to get blood tests. Because if a person has had a heart attack, for example, there will be chemicals, or there could be chemicals in the blood that indicate that. There will be proteins and elevated things in the blood. So blood tests are scientific data. Another thing that the doctor might do is order a stress test, where either Sam runs on a treadmill, or if he isn't able to do that, they can elevate your heart rate with chemicals, a chemical stress test. He might also order an ultrasound. So we could look at this almost as 3 different experiments that follow a certain plan exactly. My blood tests are done exactly the same way that Sam's blood tests are done, and it is based on science. So the experiment would be step by step following the plan. Okay. Data analysis is our next one. And data analysis means to study information from an experiment. So all of the blood tests, the stress test, the ultrasound go back to the doctor, and he will study that information. Okay, and the reason is to compare it to the hypothesis. Okay, so how do you do it? The first thing you do is gather the data. You take all of the blood tests, all of the ultrasounds, everything that you did, and you gather it up together. And then you organize it. You put it in a spreadsheet, or you put it in some ordered form. And then you make comparisons. Okay, so you will make comparisons to what? What are you comparing to? What is that control standard? That it's one of your vocabulary words. It is a standard for comparison. It is called the control. It's the normal. So the story we're following, the doctor's going to gather all of Sam's tests. He's going to organize it. And then he's going to compare Sam's results to what a normal heart would look like. So in our example, the doctor will receive all the test results. He will study them. And compare them to normal. A person who has no heart problems compared to Sam's. And then the doctor will have to decide if what his conclusion will be. So conclusion means to decide if your hypothesis is true or false. You have to decide if your educated guess was the right one. And to do this, the first thing you do is look at your data. Okay. Number 2, if data supports your hypothesis, you will say that the hypothesis is accepted. If your data does not support, this is not really another step, it's just part of the same one. If there's no support for your hypothesis, you will reject the hypothesis. So it's either accepted or supported or rejected. You could sometimes, I think supported is a better word here. You either support or reject your hypothesis. So in Sam's situation, let's say that the ultrasound showed what's the word I want? Limited blood flow let's say that Sam did not pass the stress test, meaning his heart could not hold up to stress. And then that the blood work, well, let's just say that the blood work was normal. Because this is usually how research works. You're not going to have 100% support for a hypothesis or 100% rejection. It's going to be a mixture sometimes. So these two things do support the idea that Sam has a heart problem. The blood work being normal would not support that. So the doctor's going to have to draw some conclusions here to determine what he believes is happening. If there's limited blood flow and the stress test was not a good experience, I think the doctor would be likely to say that Sam has medical conditions or medical Yes, let's use the word conditions. To suggest a heart problem. Sometimes blood work is normal, especially if the person has not had a heart attack. Or maybe the doctor did the wrong blood test. Maybe they need to do more tests to see exactly what's going on. But just because the blood work was normal does not mean that we just throw out the whole hypothesis. So, the conclusion is going to be, let me go back and review my hypothesis. The patient has a heart problem. That's the hypothesis. Okay, the conclusion confirms that. The conclusion supports that hypothesis. So we would say as our conclusion, the hypothesis is supported, or there is support for the hypothesis. That's why it's so important to write your hypothesis in a statement that you can test. And let's go back to our hypothesis card, and let's make sure that we add in the what it means. It must be testable. You have to be able to design an experiment that will test your hypothesis. That is so important. It must be testable. Okay. All right, back to, that was conclusion. We finished that one. So the next one is going to be share the results. And what it means. It means to tell others what you found in your experiment. Now you can do this by publishing it in a journal. You can publish it in a book. You can do it in lots of ways. A lot of people will publish their experiments so others can read about it. Publish in a journal or a book. You might present it at a conference. But in this situation, how is this doctor going to share the results with Sam? You can simply tell people. It can be as simple as just talking to other people. So in this scenario, the doctor is going to tell Sam, and probably prescribe treatment. And that treatment could be another test. It could be asking more questions and then prescribing medicine. It could be anything that the doctor feels is the appropriate course of action. Further research simply means that you do more research if it's needed. And in our story, I think it's needed because this doctor is not just going to say, okay, Sam, you need a heart transplant. He can't possibly do that without further investigation. He might order a CAT scan, an MRI, a more in-depth study. He might prescribe a medicine to see if it will help Sam feel better. That's where the doctor's knowledge comes in as to what you would do. If necessary, how you would do this would be to conduct another experiment. And remember, an experiment must follow a scientific plan. It's not just a stab in the dark and hope this is going to be the best thing. It follows a very defined process that can be reproduced. So in our example, let's say that the doctor orders an MRI of Sam's heart and prescribes a drug to lower Sam's blood pressure. Okay, that's further research. Those are both things that follow a scientific plan that will give more data. Okay. So we have the steps of the scientific method with an example. Now I want to go back to your text for just a second, and I want to look at these arrows that we annotated when we did this process. This is a similar version of what we just did. So let's start here with ask a question, and let's follow these arrows to see what this diagram is saying to me. So first we ask a question, and then we do the research, and then we make a hypothesis, an educated guess, and then we test the hypothesis, and then we gather and analyze data, and then we make a conclusion, and then we share the results, and then we do further research. This is what I want you to notice. The arrow that goes back to the beginning. So the process can start all over. It may be that when you do further research, you realize, hey, I need more information. Or my question, the doctor may realize, hey, this is not at all a heart problem. This has to do with breathing. So sometimes further research can start this process all over again. But you can't skip steps. You cannot skip steps. You must do the process in order. That is the thing about the scientific method. It has to follow the step-by-step sequence. Okay? All right, one more thing I want to do here. I want to go back to our pieces that we've been working on. That is graphic organizers. Sorry guys, I'm still getting used to this book. Here we go. And I want to go to the one about experiments. So let's find this experiment piece. And I want to add our vocabulary in here. Let's just put some terms in here. The control in Sam's situation is a normal heart function. So that's what we're comparing it to. In Sam's situation, we would be comparing it to a normal heart function. Okay. The constants, there would be several constants in these tests. Each test would have things that cannot be changed. For example, on the blood test, the constants would be the expected values. These are things that are standards for comparisons. A factor that doesn't vary in an experiment. So again, for example, if Sam and I are at the lab the same day, having blood tests done for the same thing, Sam's blood test and my blood test, the process would not vary. it would be exactly the same for us both. Okay, and I'm going to leave it right there for those two. We'll get independent and dependent variable in another place, but I just wanted to add those in. Okay, what you need to do is to fold the pieces that you've just made. Here's one piece. Okay, I'm going to want you to fold it on this line. So just fold that piece of paper in half so that you're closing it up. And then let's bring them over here, and we are going to put them in order. This is the closed folded paper that you just did. Which of these pieces that you just filled in is the first step of the scientific method? Well, it's going to be question. So on the outside of that question piece, let me go back. Here's the one that says question. So you fold it in half. And then on the cover, once you fold it, you'll have a space on the outside. I want you to write the word question. So question is the first step in the process. And this is the folded piece. It's folded closed. And let's just get this down, and then we'll talk about why I'm asking you to do this. Okay, what is the next step in the process? After question, let me be sure I have, yes. After question, we would do what? Sam starts to feel bad at home. He starts to think, I look a little pale. What was the next thing he did? He began to research the situation. He may have Googled it to see what would cause somebody to feel that way and to be pale. What are some of the causes for that situation? Okay, then he decided to go to the doctor as part of his research. What was the thing that the doctor did for Sam? The first thing. He said, I believe you have a heart problem. Well, that is a hypothesis. And while we have this piece, go ahead and open it up and let's add a couple of things. There's something I want to tell you about hypothesis. Let's just put it in what it means. Well, I don't have room. I'll just put it down here. Hypothesis is singular. This is a grammar thing, but it's important that you know these words. So a hypothesis, that's one. It's singular. If you're talking about more than one, you don't call them hypotheses, you call them hypotheses. That's more than one. So that's an important spelling situation. If you need to write the word hypothesis, you're talking about one. Hypotheses, you're talking about many. Okay, back to this. So we've got 3 of our steps. What is the step after hypothesis? So once the doctor says, I believe you have a heart problem, what's the next step? Well, it's that experiment step, where the doctor will send Sam for controlled experimental testing. That is the 4th step in this method. Now, you can glue these down in order. Just put glue on the back so that you can still open the little flip. Or you can just put them in an envelope and keep them so that you can put them in order. I would almost say just put them in an envelope and then you can practice sorting them when you want to practice the scientific method. But it is entirely up to you. The thing that I'm concerned about is that they are hands-on. I want you to be using your hands because that helps your memory, and that you know the right order to put them in. So if you're not going to glue them down, you want to be sure that you would know what the correct order is. So this is one. Well, if I do that, you can't quiz. Practice. You might put a 1 on the inside. Let's do it that way. So let's go back to question, and on the open it up, and on the inside let's put a 1. Research was 2. Hypothesis was 3. Experiment was 4. So what's the next one? What's the piece that comes after experiment? Once you collect your data, you have to analyze. So data analysis. And while I'm thinking about it, let's go back to that card. That's number 5. And let me show you that analysis is singular. That's 1. And just like with hypothesis, we did that suffix analyses is more than 1. So it follows that same spelling pattern as the word hypothesis and the word hypotheses. Okay, on this one, after you analyze your data, what do? What's the next step? You make a conclusion. This is where the doctor told Sam, or where the doctor decided, yes, I believe this gentleman has a heart problem. After the doctor knows what the problem is, the next step would be to share those results. And is that what we called it? Yes, it is. So number 6 is conclusion. Number 7 is share results. And then the final step, which can lead to this process starting all over again, is further research. Now, if you want to glue or tape these to your notebook, you want to make sure they're in this order. They're folded closed and that they're in this order. If you want to just put them in an envelope so that you can sort them again, you want to make sure that you know the correct number. So you could practice sorting these almost like flashcards if you don't want to stick them down. It's entirely up to you. When I was in college, the professor had us to glue them down so that we could quickly go through the steps if we needed to. We also did quizzes on these where you close all of the lids or the tops, and then you ask yourself, do I know what's under there? So for example, under the question tab, what does it say? What is it that I'm supposed to remember about questioning? So if I were doing this for myself, I would glue them down in this order. When I was in college, I also wanted to color code them. I would color each one a different color. That's entirely up to you. That was just one of my study skills. But this really helped me when it came time to review for a test. I could flip through those. Instead of just reading my notes, I could walk through the process that I needed to remember. So that's sort of the reasoning behind this. Okay, that is the summary or the graphic for Unit 1, Lesson 1. And we will be looking at this more in the next video. But you have your first memory piece done. And I will see you soon.